So question 9 is all about limiting reactants, and the definition of a limiting reactant is essentially the substance that, or the reactant that determines how much product is formed. The thing that is limiting will be completely used up in the reaction, and then anything that is left over is what we call our excess. Now, we don't like to say left over, but it is just the substances that remain once the limiting reactant has completely reacted, because it's very rare for you to have the exact quantities of all of the reactants that you need for a reaction to go to completion. So we're given a question like this one where we want to deduce what the limiting reactant is. So we've got 10.0 grams of copper oxide, CuO, and it's being mixed with 10.0 grams of sulfuric acid. And our job is to identify which of these is the limiting reactant. Now we're given the relative formula masses of the two substances that we're looking at, copper oxide and sulfuric acid here. So how do we approach this? Well, the first thing I'm going to do is, as always, or as I often do, I am going to write my own version, larger version of the balanced equation here, just so I can annotate it if I need to. Now the first thing I want to do after that is I want to look at the information I've got. Well, I've got the mass of copper oxide and I'm given the relative formula mass, so it feels like the right thing to do here would be to do what we always do, which is to calculate the number of moles of copper oxide. So I'm going to do that. So the moles of copper oxide, we've said already that to find moles we do the mass divided by the relative formula mass, and the mass in the question is 10.0 and the relative formula mass, which is given to us just here, is 79.5. Now we do that calculation and we get an answer of 0.126 moles. Now that number is going to be crucial. Okay, and I'm going to write this in a different colour underneath my balanced equation, because I've got 0.126 moles of copper oxide. Now what that means is that because this reaction has a 1-to-1 ratio, so 1 copper oxide, 1 H2SO4, it's 1-to-1. If I had 1 mole of copper oxide, it would react exactly with 1 mole of sulfuric acid. Now I've got 0.126 moles of copper oxide, so it will react with exactly 0.126 moles of sulfuric acid. So what that means is if the number of moles for sulfuric acid is greater than 0.126, that tells me that this substance is in excess, because the sulfuric acid will not be the one to run out first. It won't determine how much product we're forming. There will be some left over at the end of the reaction. However, if it is less than 0.126 moles of sulfuric acid, that will tell me that it is the limiting reactant. And the reason it tells me it's limiting is because the copper oxide will be in excess, because there are more moles of the copper oxide than are needed to fully react with how much sulfuric acid we have. So now we've done that bit of calculation, we can actually calculate how many moles of the sulfuric acid we have got. So let's do that. So the moles of H2SO4, once again, we're doing the mass divided by the relative formula mass, which is, once again, 10.0 grams, and we're dividing that by 98. And if you do that calculation, you get an answer of 0.060. No, you don't. You get an answer of 0.102 moles. Sorry, I was looking at the wrong question. And you'll notice that this number here is lower than 0.126. So that means that this is our limiting reagent or reactant, and this one, the copper oxide, is in excess. So what are the marks for here? Well, it's a 3-mark question. You get 1 mark for the number of moles of copper oxide, 1 mark for the number of moles of sulfuric acid, and then you get a mark for deducing that based on this, the sulfuric acid is limiting because of that 1 to 1 ratio in the balanced equation. So we move on to 9b, and this one is a little bit more complicated because we're given the balanced equation, we're told the mass of bromine that is reacting with sodium iodide, we're told the mass of sodium iodide as well. And we need to identify which of these is the limiting reactant, but then we also need to use that information to calculate the maximum mass of sodium bromide that could be produced in the reaction. So there's a lot to do here for these 4 marks. So let's see what it is we have to do. Well, we have to take the same approach we did last time. So I'm going to write out my balanced equation first of all. So Br2 plus 2NaI is reacting to form I2 plus 2NaBr. Now I'm told I've got 16 grams of bromine solution. So I'm going to find out how many moles of bromine solution I've got first of all. And once again, it's our mass divided by our relative formula mass. So we've got 16.0 grams, and we're dividing that by 160. Now if we do that calculation, we get an answer of 0.100 moles. Okay, so that's how many moles of bromine we have. If you've done that, you get 1 mark. If in doubt, find the number of moles. So now we need to use the logic, the process that we used before. We've got 0.100 moles of bromine. So how many moles of sodium iodide, NaI, will it react exactly with? Well, looking at the balanced equation, you can see that we've got 1 mole of bromine reacts with 2 moles of sodium iodide. So it's a 1:2 ratio this time. So that means if 1 mole of bromine were to react, 2 moles of sodium iodide would. If you've got 5 moles of bromine, 10 moles of sodium iodide react. If you've got 0.100 moles of bromine, 0.200 moles of sodium iodide will be needed in order for this reaction to be complete. So what does that mean? Well, what it means is if we've got a number of moles of sodium iodide that is greater than 0.200, that will tell us it is in excess. And if you get a number that is lower than 0.200, that means it will be limiting. So let's do the calculation. Let's find out exactly how many moles of the sodium iodide that we have. So moles of NaI is equal to the mass, which is 9 grams, 9.0 grams, we're told in the question, divided by the relative formula mass, which we're given as here, 150. And that gives us an answer of 0.060 moles. Now we need to look at that number and compare it to 0.200, and we can see that this number is a lot lower, so therefore it is our limiting reagent. That will get us our second mark here. And also for deducing its limiting, that's our third mark. But we're not done yet, because it's asked us to use the information about the limiting reactant to calculate the maximum mass of sodium bromide that could be produced in the reaction. Now we need to remember what the definition of a limiting reactant is here. So remember, the limiting reactant determines how much product is formed. So when you're doing any calculations of masses here, you need to be using calculations with this one, the limiting reactant. So with that in mind, if we ask ourselves that question we've asked before, because we're finding a maximum mass, that's when we asked ourselves the question, what's the mass of Mr. Mole Rat? We've got sodium iodide, and we want to know how much sodium bromide we're going to make. Okay. So the mass of sodium iodide, we've already looked, is 9.0. We've divided that by the relative formula mass already, 150, to get our number of moles, which was 0.060. Now let's look at the balanced equation for the ratio. So we've got a big 2 in front of sodium iodide, so I'm going to pop a big 2 there. And then we've also got a big 2 in front of sodium bromide, so I'm going to put that there. So it's a 2:2 ratio. which we can simplify as saying it's a 1-to-1 ratio, because however many moles of sodium iodide we use, we're going to get the same number of moles of sodium bromide. So what that means is the number of moles of sodium bromide that's being produced is 0.060. Now if we put in the relative formula mass, that is 103. We divided going down the other side, so we're going to multiply going up this side, so we're going to do 103 multiplied by 0.060, and we get an answer of 6.18. So 6.18 grams is your final answer and your fourth mark. Now this is a very tricky question and is probably the trickiest kind of calculation you could end up with on your chemistry paper. So if you feel confident with this, amazing. That means you're in a really good position going forward. Hopefully that has been helpful.